Okay, this is the map I'm talking about, and Dorothy had a privilege of seeing a movie that I'd made with this map, a time-lapse movie, and I wish I had a PowerPoint projector and a screen, because if you see this movie over time, basically it shows the populating of the earthquakes over time. It's pretty, it impresses me, I mean, how it works. But what we have here, this is basically essentially the Fayetteville Shale Play area. This is Searcy over here to the east. We're coming across White County, Faulkner County, Conway County. Morrilton sits over here to the west, just off the map. This is Greers Ferry Lake here, Clinton up here. So this is Van Buren, Cleveland County, Independence County. And we'll turn this map around. So this was kind of the first screening tool that we did. Basically, we took this map. All these yellow dots you see here, all this right here are the production wells. All this right here are the production wells. The earthquakes are the colored dots. The size of the dot represents the magnitude. The color represents the depth at which the earthquake occurred, which is very important. These gray lines here, you see these large gray lines that cross, these are the faults. These are the known subsurface faults in the area. So there are numerous faults. Some of them are very large, go a long ways, miles and miles across the subsurface. Change direction, different angles, and that angle is going to be a little bit important here as we talk about it. Now, so you have the yellow dots are the production wells, the faults here. This is the old earthquake, the old Enola swarm here. That's the lighter dots here. So you can see there's only 10 miles difference from where the Enola swarm occurred back in 1982, completely natural, and where the current Greenbrier, Guy Greenbrier swarm is going on right now. Just for your reference, this is Guy, this is Greenbrier. So again, this is the Guy Greenbrier fault. You can just draw a center line through this massive earthquakes, and you can see where the fault lies. This was a previously unknown, unnamed, unmapped fault. This fault is very old. It was probably the genesis of this fault was related to when the New Madrid fault formed, on nearly the same angle as New Madrid. So the genesis was most likely at the same time. This fault is deep. In fact, this east-west fault, which is called the Enders Fault, actually cuts the fault here and drops this fault down. And you can see the earthquakes actually drop down in depth on the down-thrown side of the fault. It's pretty sharp. So it's a very old fault, and it's favorably oriented because it is the same orientation as New Madrid. It's oriented favorably to the regional stress, which is basically like this. So because it's favorably oriented where these are not, these are parallel to the regional stress. This is a little bit more parallel to it. It's not as favorably oriented for the stress and strain to accumulate on it. So you have a fault that's favorably oriented. It's set, it's ready to go. It just needs a little push. And we're wondering now if there's not another one of these faults that lay under here where the Enola swarm is. Of course, we didn't have the technology back then to know for sure. So that's what we're looking at. Now, the key thing is the injection wells. Injection well, injection well. These are the red with the circles, injection well, injection well, injection well, injection well. Those are the reds over here. So when we populated this map, we said, okay, where are all the earthquakes at? Well, you've got all these thousands of production wells across the area. If there was a relationship between the earthquakes and the production wells, you would expect earthquakes all over this map. You don't see that. I mean, you've got a large density of production wells here and here around these faults. Yeah, you got some scattering of seismicity, but if you look at the historical seismicity, you see the same thing. What you do see, however, are these clusters of earthquakes here, here, and of course this cluster here, this cluster up here, and then this cluster over here. And the key is these clusters, around these clusters are injection wells, injection wells, injection well, injection well, injection well, injection well, injection well. And so with that really keyed us in on taking a closer look at these injection wells. And that's why our focus has been. Now this black box here you see is the moratorium that was issued by the Oil and Gas Commission back in January that no new injection wells can be drilled in this area in response to the activity that was ongoing. Now that did two things. One, that kept any new wells, because there was 2 more wells that were slated to be drilled in this area. One, that kept it from becoming more complicated. And then the second issue is as part of the requirement is each of the companies, which are 7 wells that are operating in this box, they're required to give us their injection data, their daily injection data. With that data, we're able to look at the frequency of earthquakes versus how much they're injecting, at what pressure they're injecting, to see if we see that correlation that we saw that was seen at Rocky Mountain Arsenal, which is kind of our example of how we're doing our study. But again, this is kind of our first, this is what we use to kind of say, okay, we need to look further at the injection wells versus the production wells.